Good afternoon, everyone, on this very sunny Friday afternoon. Welcome to our Software Development for Business session. My name is David Aaron. I'm the Marketing Communications Manager for Graduate Apprenticeships here at Heriot-Watt. And I'd just like to thank you for taking the time to join us today. I'm just going to cover off some quick housekeeping before handing over to Santi, who is the Programme Lead for our Software Development Programme. The webinar is being recorded. All the lines are automatically muted, but you can still use the Q&A function on the right-hand side of your screen to ask any questions. And what we'll do with that is we'll cover off those questions at the end of the presentation. So without further ado, I shall hand you over to your presenter today, Santi. Over to you.
Thank you, David. Good afternoon, everyone. And also, we'd like to thank you very much for attending this presentation about the Software Development for Business program. I am Santiago Chumbe, Santi, and I'm the director of the program. And basically in this webinar, I will cover 4 aspects of our program. First, I will describe the main features, the main characteristics of the program. Then I will show you the modules, the courses, the content that we teach. Next, I will describe how we teach this content in practice. And finally, I will outline the main outcomes, the main goals, the main learning outcomes that we would like that our students achieve on graduation. So let's start giving an overview of the main features, characteristics of our program. Our program comprises 4 years, and at the end of the 4 years, the student get a BSc degree, honors degree. The students need to attend university 1 day per week from the first year, and that happens every year. So we expect that the students that be attending lectures, labs on campus once a week. Also, the student need to allocate 6 hours, around 6 hours per week, to study on his own time the material that is not possible to be delivered in the day that they are on campus. So it should be around 6 hours per week. We deliver the courses in 3 semesters, which is more or less 42 weeks. Most of the lectures, practically all the lectures and labs and the days that they need to attend, they need to stay on campus, happen in semester 1 and semester 2, which is more or less between September and April. Semester 3, which is normally start at the end of May and ends at the end of July, normally is to do the industrial projects. The students don't need to attend the university except a couple of days, and they do the work with our support, online support, and also by emails. So we help them to complete an industrial project. So normally we start at the middle of September and we finish the first week of August. So that's normally what has been happening in the last 2-3 years. The students have holidays in Christmas, everybody has holidays 2 weeks in Easter, and then in summer, though in summer they need to be attending semester 3, we have programmed the industrial project for semester 3 in such a way that the students will still have the chance to have their holidays. Our lecturers also can have their holidays, 4 weeks of holidays. Normally that happens between the 2nd week of June and the 2nd week of July. The students are always supported by a personal tutor here at the university. Each student has their own personal tutor, and also they have a work-based mentor at their workplace. Normally this work-based mentor is the line manager at their workplace. So this is the big picture of program, how it's delivered. Now I'm going to talk about the material, the modules, the courses we teach in these 4 years. We can group all these materials. We can classify all these materials, these modules, in 3 big groups. One group of modules aims to teach the students the basic, the fundamental software development meta skills. We talk about meta skills because we teach skills that are permanent, that can be adapted, that can, depending on the circumstance or dependence of the demands that the students will face later on. For example, we don't teach to program Java. We don't teach to program in Python. We don't teach Python. We don't teach Java. We don't teach C#. We teach how to program in general. So we want the students to learn to program, to create, to write secure, robust, reliable, maintainable software. It doesn't matter the language they will use to do that, that we need to use to do that. That depends the language they will be using at their own workplace. We will not force them to use Java, to learn Java, for example. We will not force them to learn Python. If they are, but we will make sure that they learn to program using the best practices, the standards that every software engineer should be aware and should be able to use. That's what we always aim on teaching meta skills, something that is permanent, that regardless of what happens in the future, it will still be valuable for them to know how to program rather than knowing just how to program a specific program. This is just an example. The same applies when we teach databases or we teach other materials that are part of the program. The another group of courses are the courses that aim to teach the students to really develop software engineering projects, because creating a software is not just a matter of coding. We want our students to be able to know that there is social implication, economic implications when they develop a software. They need to see the complete engineering project associated to any software development, from the moment that they are aware, they made aware of the business requirements, considering the risks. They need to do risk assessments, the economic implications. They need to do how to gather in the proper way the requirements from the users. They need to design the software, the tools that they need to use for designing the tools, the development, the testing process, the maintenance. So all this complete cycle that every software engineer has to be known, has to be taught to the students. So at the end of their 4 years with us, they should be able to really create, manage, and comfortable work as part of teams developing software engineering projects. The last set of modules we teach have a combination of computing and business courses, because the idea is that the students should be able to apply their software skills to make an impact in their company. Normally, we are focusing a lot in being able to help the company to discover knowledge, to get the most of the software applications they are using at work, and also to be in contact with the business requirements, with the marketing, with production, with other type of members of the staff and their companies, to see that they are just one player in a big team, and where the aim, the final aim, is to really help the business to be profitable, to be efficient, not just creating software. So this is the 3 main groups of type of materials we teach, and we teach this one in modules, and most of the content is computer science content, and it's almost 80% of the modules we teach cover computer science. When we say computer science, we have adapted the original computer science syllabus we have used to create this program in such a way that we have removed some theoretical aspects that are relevant for professionals who are going to focus, for example, in developing PhDs or doing research. And we have replaced these topics with more practical, more industrial relevant topics. So that's our computer science component. We have a 20% component of business, because we also need to know the context. They are working in a business. They should be able to know that how the business people require the things and how they can make an impact in the business needs. No, so they will cover from basics of accounting to human relationships when they work with people who are, for example, not familiar with the jargon we use in computer science. So they should adapt. They should be able to communicate jargon things, computer things using the language that business people use. So this aspect is covered by more or less by this 20%. We teach these modules in three different delivery types. Almost half of the modules are taught on campus. So they need to come, the students, 1 day a week. They join our regular lectures, and they receive lectures, they attend lectures, and they participate in the labs. And also they receive online material. We develop online material, online assessment. They will need to use this online material on their own. So normally they would require to spend 6 hours doing this online study. So combining this self-study they do in these 6 hours plus the 1 day a week study they do on campus, we have this 50% of blended learning. 5% of the courses, the modules, are actually taught using what we call the work-based learning, where actually the 35% comes from the things that the students are learning at the workplace. So it's very important that the student is working in the right place, in the right environments, because that will help us a lot, will make it really very easy for us to achieve this 35%. Whatever he's doing at work, which is relevant for computer science or business computer science for our program, will be assessed, evaluated, and will count as a credit for the student. 50% of the modules actually are industrial projects. The main part of the industrial project happens in the 4th year, because the student need to create their dissertation, their final year project, which will give you the degree. So normally in the last year, in the 4th year, they need to do a real software engineering project, very relevant for the company. This project is very important, the role of the work mentor, the work supervisor, the line manager, because the project really has to be something that's useful, some meaning for the company. So these are the 3 types of delivery. Now, these are I'm showing just now the courses, the modules that are part of this program. What we teach in year 1, you will see that we have one industrial project in semester 3, which is software development methods. It's a very initial, very basic project. And we have in semester 1, we have 2 courses which are taught on campus. These courses are important to give the fundamental meta skills to the student. The same happens in semester 2 with 2 other courses which are very important. They give the fundamentals of the computer science. And then they have 3 courses which are actually work-based learning courses: Introduction to Computer Systems, Industrial Practice, and Internet Technologies. Something similar happened in year 2. Year 2 again, they have in the first semester 2 courses that are taught on campus. The same happens in semester 2. And then they have 4 work-based learning courses. The work-based learning courses happen across all the semesters. They can start in semester 1 and finish in semester 2 or semester 3. In year 3, start to have most of the business aspects, most of the business content happens. There's 3-4 courses that are focused on business now. They have relationship with the computer context, but they are taught, they are provided by our colleagues from the business school. They still need to attend and study computer science courses, of course, artificial intelligence, which is a very fundamental course now. They need to know. They need to know data communication, networking, security of computer networks. So these are still fundamental courses for them. They need to do the complete software engineering project. This is a kind of draft project for them to be ready for 4 years for the final dissertation. They need to see the ethical aspects of software engineering when they will do the professional development module. They need to see that what are the implications, the human implications, social implications, ethical implications, professional implications of a software engineering. No? So this software engineering course and professional development course go hand by hand because goes together the technical aspect, the economical aspect, and the professional, the human aspect together. Year 4 is actually the final year dissertation. They still need to study computer network security because security is very important. But they will start to do the industrial project, starting with the methods they need to apply, to use, to gather, to know, to find the business requirements. They will then from semester 2, they will start to do the design, the implementation of their software engineering projects. They need to do the testing, and finally they need to defend. They need to do a kind of BIBA of their project, no? So that's the big dissertation. Still, they also will need to continue doing work-based learning. In this case, they will do the data mining, which cover from the business analysis of the requirements to the development of some models to do data mining, data analysis, and machine learning, combining with machine learning algorithms. They do also wireless communication, programming of this wireless environment, and they also need to complete their business skills with project management and strategic management, which is linked with the business aspects of the program. This is the big overview of our program from the structure point of view. Now, how we teach in practice these courses, specifically how we deliver the work-based learning and the industrial project courses, because this is something unique, something new in our university, specifically for the GA program. I can highlight perhaps 3 styles, 3 ways that we use to teach these courses, these modules. We use some style which is called the self-paced learning and assessment. We try to personalize, to customize what we are delivering, taking into account the needs of the student and their employer, their company. For example, imagine the students join one course, one module. Everybody starts at the same time. Start the semester, start the module. Some of them might have previous experience or might be doing things at work that actually allow them to meet the learning outcomes early. So they don't need to stay attending. They don't need to stay all the semester doing the course if they already have evidence that they have covered all the material, all the learning outcomes of the course. So perhaps before the middle of the semester, because we will be in constant interaction, in constant contact with the student, we will notice, talking with them, evaluating their work, that actually they don't need to stay all the semester with this course, and we can free their time so they can focus on something else, in another course that might need more support. No? So the students will be advised and will you help it to complete the course early. Some students really have enough skills and knowledge that they can be exempted from doing the course completely. So it's very important, the role of the personal tutor and the mentor, because from the start we need to identify the skills that the student is bringing or is learning at work, so we can help them to make the most of their time. So some students will be exempted. Okay, one course less to do in this semester, so you can focus in other courses or in your work. Some students, excuse me, of course, they will need to attend all the semester because they don't have enough knowledge, experience, or they are not developing these things at work. So no problem, they will attend all the semester. That's happening with our on-campus students, with regular students. Some students might end a little bit early. So the idea of this style of teaching is that it's personalized, it's customized. Another teaching style that we use is what we call the cross-course work-based and industrial project evaluation. Normally, in traditional teaching, in traditional courses we teach at the university, each course has its own content, its own labs, its own coursework, assignments, lecture. It's a different team, everything. It's totally isolated in some way from other courses. Okay, and each course has their own assessments, their own exams, their own labs, their own courseworks. However, because we have noticed that in real life, in practice, the work that the students are doing in the workplace actually is not only just about databases, for example, it's not only just about coding something specific. It's actually the thing they are doing is touching many aspects that are covered by different courses. What we have done is try to get the most of that aspects to again save the time to the time of the student and save the time of the company. So basically, for example, I want to show you just now an example. What I'm trying to tell you. Imagine that the student is taking 3 courses, studying database management systems, and also studying a course on software development, and also is studying software design. So the student, rather than being asked to do 3 different courseworks, 3 different projects, each for different course, what we do is we ask them to do 1 project. The 3 lectures, the 3 course leaders work together to design 1 assignment, 1 project, which will allow the student to focus in 1 coursework, and this coursework will include elements from database management systems, elements from software development, and elements from software design. In this way, actually the student will end up doing only 1 project, which is good. 1 project, 1 coursework, 1 assignment for 3 different modules. Again, this is closer to what happened in real life, and also we have noticed, based on previous experience, that free a lot of time, the time of the student and the so that's the second style we use. The third style we use that I would like to mention here, we have another styles too, but I brought here for this webinar only these 3 ones, which are the ones that have received good feedback from our students and our employers. From the very beginning, what we do is to try to match the learning opportunities that the employer is offering to the student. Each company has their own context, and because they are doing software development, we are sure that we can find the learning opportunities in that company. As long as the company develops software or the student is working in a department which involves software development, is perfect for us. And if the student has the opportunity to interact with the business aspects with the other departments of the company, much better. So working with the work mentor, normally we identify the learning opportunities that is happening in the workplace, and then we try to match that with the requirements, the workplace requirements, the assessment requirements that have each module. That way, when we give an assignment to a student, we give an assignment that is coming from their own work, which is relevant for their work. So the student will not need to do an artificial assignment, an artificial coursework, something that is made up by the lecture. No, it will be something that he actually is doing at the workplace. So this is very important. So in order that this style can work, the employer needs to provide the work environment and the learning opportunities, so we could identify the things that we can use from that work environment, the learning opportunities that the employer is offering, so we can identify that and use them embedded in our assessment process. And also, we can use that to customize even the content we are delivering to students. So because we can personalize a lot the content of our courses, we use what we learn from the employer and from the employers to customize, to adapt the content, the assessment of our models to that requirements. So this is in practice the three main teaching styles we use to deliver our modules. Now, at the end of the 4 years with us, we aim that our students have gained really the foundations of computer science, be a confident professional, able to create secure, robust, maintainable software. And they are totally confident and familiar with the terminology, with the technology, with the jargon of computer science. They should also be able to be creative, to have the opportunity to have been faced with problems and given the opportunity to develop their critical thinking, their critical approach. No, we try to every year we always are challenging them. So at the end of 4 years, they should not be afraid to facing problems and giving their solutions. That's the point of doing the dissertation. The dissertation has to be something unique in some way, that is the contribution that the students are going to make is going. We show them that it's don't be afraid to bring their own ideas, no? And the students should be reliable professionals. Every computer science professional is able to be a hacker. We know that, so they should be able to. They should know that it's like a doctor. A doctor can kill a patient, a person. So also they can damage the company. So they need to learn that the ethical, the professional competence. They are professionals and they need to behave as a professionals when they work. It's not. They are not just coders or software developers, hackers. They need to know the project management, the business aspects of the managing a software project, you know, and how the project is managed, involving people, risks, you know, not only just technology, and they should be able to apply their fundamental skills to develop solutions. Could be in any aspects. Could be data science, in business, in e-commerce, web analytics, or how to create, for example, an e-commerce that retain the customers, how to help the marketing, or they could create complex databases, no? Distribute databases. So they should be able, or they should implement solutions for the health sector. No, they should be able to use the artificial intelligence aspects that they have learned to create solutions. They should be able to create autonomous systems, so they can create systems, analogic systems, digital systems work together. No, so they should create solutions in different aspects of our society. So at the end of the day, what we want is we want to produce competent software engineers. That's all about the description I wanted to give you our program, and I really thank you very much for your attention. I give now the platform to David.
Thank you, Santi, for that great insight into the software development for business program. Thanks a lot for that. That was really good. So we have a few questions, so I shall do my best to read them to you, Santi, and we can go through them. So a good range, really, just in terms of someone's just about the sort of process, and also maybe some specific ones on the curriculum. But anyway, I shall just kick off. So I suppose going back to the start of the process of onboarding a new student, what do we do to make sure that the job that the role that they're in is suited to the degree?
And the best thing is that the student is not the only one doing software in their workplace. It should, in our experience, is the students who are not in a kind of software environment find very difficult or challenging to progress further in the best way possible. So, for example, that's crazy. It's crazy what I'm going to tell you. Perhaps if the student is in a restaurant, in a kitchen, is in the wrong environment, the wrong place. The student has to be in an environment where software development is happening. At least has to be 2 or 3 colleagues that are doing the same. For example, if the student is just supporting, answering calls from end users, it's not even the questions are about computer things. It's not the best place. The student will need to have the opportunity to do hands-on, need to develop, need to create things, need to really create things. So basically, the student should not be on their own doing software development work. The line manager should be somebody who's working in the software environment. And it's very important that they are supported by the line manager, because we will interact a lot with the line manager to identify the learning outcomes, learning opportunities at work, and to design, to customize the material we want to teach them.
Okay, perfect, thank you. Kind of related to that, just following on from what your last point there was, there's a question in here around how to be a mentor in the programme. Maybe that's round about who should be a mentor, or how do they become one? The
students need a lot of support, not only technical support. Sometimes they need a lot of encouragement. So it's more or less what we do when we nominate personal tutors. We try to match personal tutors that can go with the character more or less with the students. We do a first interview with the student just at the start of the semester, the first semester. And then based on that interview and talking with colleagues, we designate the personal tutor. Something similar should happen in the workplace. Should be somebody who can provide support to the student, because the students will find sometimes it's normal, sometimes we'll find difficult, we need support, need to find that the company, the employer is not indifferent to their efforts they are making. Should be somebody who knows the material. It has to be someone who knows software, who knows the material. And normally, a line manager. We try to don't disturb the work mentor, because we know they are working. They have their work, of course. So, but it's important that they be someone that can talk with us. No? We don't ask for big meetings. Normally, it's just specific questions. We have already some material that we have produced based on our previous experience to make easier, faster the communication with line managers, work mentors. So they will see, we try that they see quickly what they require, so they don't need to spend too much time telling us what their students are doing, because we want to know what the students are doing, so we can identify what we can use and what the students do at work for our teaching, for our assessment. So it should be somebody who is supportive, who is sympathetic, who show the student that the company cares, is with them and supporting, and somebody who can give us some time to interact, so we can work together to help the student.
Great, thanks. I've got a couple of questions here which are maybe more specific on the course content itself. So there's one here, with security breaches on the rise, does data security form a part of the curriculum or assessment process?
Yes, security is very important. Data security, network security, software security, business security are part of the curriculum.
Great. Okay, that's an easy answer. So again, just looking through the questions. So there's one in here. There's a question here, Santiago, about Will there be during the course of the degree, is there a point where the student will learn how to take an off-the-shelf software program and adapt it to suit the requirements of the business that they work for?
Yes, that's what we really want to promote.
Yeah,
that's a big yes. Yes.
So that's just like an ongoing thing throughout the. That's basically one of the underlying goals of the whole degree, isn't it?
Yes, that's one of the main points.
Yep. There's another one here just in terms of sort of project work. So the question is, how would the person show evidence that they had already done something? I'm not entirely sure if this means prior to joining, or I'll read the rest of the question anyway. How would the person show evidence that they had already done something to avoid having to repeat it? Is that like through work projects or something?
Basically, we want to see the transcripts for any grades that they have achieved before in the school or in college or another university. So we have a look. We revise the prior knowledge they have, and also we ask for we have an interview with the student, and also we will talk probably with the company to find out what the student has done or is doing at work. So more than just documents, apart from the transcripts, is talking, and sometimes we visit the company. Actually, we always visit the company to see the place where the student is working and talking, interacting. We find more. We don't. That's mainly what we do. So it's an interview. It's meeting with the mentor, with the student in the workplace, and asking for transcripts.
Perfect. Okay, thank you. Another quite a kind of specific one here, talking about impact on sort of the workplace. So the question is, so will a student be taught how to duplicate a test environment so as not to impact on real-time business operations?
Yes, we don't want to impact the business operations. We know that the students. So what we do is sometimes we have our servers. We have computer servers in our department that we use for. We make available these servers for the student to create what we call the staging or the development servers, so they can do their applications there. We never will try to interfere with the normal work of the company. So sometimes we need to adapt or degrade our requirements in order that doesn't impact the normal work of the company. No? So sometimes we also agree in removing things from their work, for example, because it's confidential material, confidential data. So the nice thing of this program is that because the rate between between number of lecturers and number of students is very low, which practically look in on-campus courses. Sometimes we have one lecture for 80 students, but in our program is one lecture perhaps for 10 students. So it's very easy to interact with the students, to find out the best way to adapt our requirements, to find the best way to help them to implement the assessment we ask them to do without disturbing, without asking them to modify what they do at work.
Yeah, great. Okay, thanks for that. Just a couple more. We're nearly there. And this one here, I think, for me is one of the sort of key benefits of the whole GA program. The question is, in your experience, how fast can a graduate apprentice transfer their learning to the workplace and therefore add value to their business?
It depends with the prior knowledge that the student brings to the program. But I will say that imagine we have a new student just coming from high school, 17, 18 years old student, no work experience. The student will not be able to be honest, will not be able to really have to provide a big impact in the first year. The first year will from what he's learning at work. Of course, they will also learn at workplace, but from what we are teaching them in the program in the first year, they will not have all the skills, all the knowledge to really start to have an impact, to produce an impact at work, because they will just receiving, they will be like a sponge. The first year is a lot of getting. From the second year, the things start to change, because now we start to encourage, we start to include in the work-based assignments things that the students are doing, but this time we start to push them to start to try to bring solutions to the things, to their work, and this becomes super important in third year. In third year, practically, they need to be always talking about work. They need to always bring in work things in their courses. We want that in the courses that they are taking in third year and in fourth year, always be something that could be relevant for their work. So we think that definitely after the second year, the student will be just focused in creating impact, creating benefits for the company. Of course, they are learners, they are not professionals yet, so they will start to have an impact. At least they will start to know that it's very important for them to produce impact in our companies from the second, third year.
Perfect, thank you. And last but not least, just one to go, Santi. Again, just to give, I guess, some context or some background for people listening in, is what types of company so far have we had already on the program?
We have big companies. We have 3 big companies. They are multinational companies, and we have very small companies from Edinburgh, and there's a company that is developing apps, and so we have also from organizations that are not companies.
Is it across a range of sectors?
It's very variable. It's very variable. We have companies that have their own training program. So they are, with them, the work is really very good, because we really meet with they have their own team that manage the training at work. So we talk a lot with them, because we need to make sure that our structure, with the structure and with the structure they have, go hand by hand, go in harmony, complement nicely. So that's one aspect. When the company is small, for example, the interaction with the line managers has become very important, and so far has worked nice.
Great stuff. Awesome. Thank you for that. That's all the questions that we have. So that's great. I'll maybe give it a wee second because of a slight delay. In the meantime, I would just like to say to everybody listening in, I hope you found that a really useful insight into the Software Development for Business program. I would just like to thank again Santi for the presentation. That was great, Santi. Thank you. And thanks to everyone for joining the session today.
Thank you, David. Thank you. And thank you to everyone for attending this presentation. And I will be happy to answer more questions if you let me know.
Exactly. So, yeah, I mean, what I'd encourage people to do is, if you have joined anonymously, which can sometimes happen with the Microsoft Teams live event, please drop an email into our mailbox, which is on the screen just now, and feel free to ask any questions, and then we can pass them on to Santi and the team to answer any sort of, even if you go into sort of more detail. And also, and if you do drop an email into the mailbox to let us know that you have joined the session, do so, and we'll make sure that we send you a copy of the slides or even a link to the recording, and that would be great. And we will be running more of these events, so keep an eye out for those on Twitter and LinkedIn. You can follow us on both of those, and we usually promote these type of events on both of those platforms. So really appreciate your time, everyone, and with that, I would just like to say thanks again to Santi, and thank you all for attending.
Thank you. Bye now. Thank you very much.